Hey YouTube, another project video here. This is actually more of a sub-project that was born out of that prop laser pointer, which I still haven't posted all the videos associated with them yet. But one of the conundrums I was faced was, how do I get portable battery power? My first iteration was using 3D printed lithium polymer battery cases for remote control, like airplane batteries, which, while they have high power density for the weight, while they have extremely high current output, 30 to 60 amps in a little tiny package, they're soft-walled, so they could get damaged, you can get crushed. Short circuits are typically catastrophic with a decent amount of fire involved, so that's a risk that my projects in the past have had to take on. Plus, battery management is a problem. These two little blocks here, if I bring it closer to the camera, these are actually little buzzer units, which I'm going to plug them in. They make a loud noise. So basically these units tell me the voltage for each cell through this balancing lead, and this is only a 2-cell battery pack, and I actually have a pair of them together. But regardless, you don't want to over-discharge lithium batteries, and you have to monitor the power through the balancing lead if you want to be able to discharge them to an acceptable level and not over-discharge them. Once you over-discharge them, it's not safe to recharge them. So, lithium polymer batteries, great for high-energy, lightweight applications, but all the asterisks and warnings simply were not acceptable to me. Right? If you over-discharge them, if you overcharge them, if you heat them, crush them, pretty much anything, kind of bad. So then I got to thinking, what else could I use for battery power? Well, I just happen to have these lovely lithium batteries that I use for my power tools. These Ridgid drills and impact drivers that I've used for years. They're rock solid. These batteries, this is the 2 amp hour version. They have a 4 amp hour version as well. Low profile, so it's not like those DeWalt batteries with the giant stalk coming out the top. But the problem is the contacts aren't exposed. They're hidden back behind here. So then I got to thinking, how can I use these batteries? This has been on my mind for a couple of years, and I haven't really been able to figure out the best way to do it, but then inspiration struck me thanks to the internet. Effectively what I've done is I've created a 3D printable battery plate using one particular part from Ridgid, the actual manufacturer of the batteries. It's actually a Ryobi part, because Ryobi, DeWalt, and Ridgid are all the same company, made by the same factory. So this plate is actually the part you need. And it comes out of this old chintzy flashlight, which I went to the effort of pre-disassembling. So you can see this clicky push button here is actually this push button here. Oops. And this lock is actually the device with the battery contacts in question. This one, it looks like they were nice and they actually used just straight up pure copper. The replacement ones seem to be a little cheaper, which don't have that. But regardless, this is the one magical part that makes it all happen. Put this aside. So I'm going to go ahead and open this up. This is actually a $3 replacement part online, so it's super, super cheap. This version has kind of cheaper, lower gauge spring contacts. They might be steel, it might be copper plated with nickel maybe. Either way, it's the same wiring harness with the correct length to fit inside this flashlight. So that's just for illustrative purposes only. In effect, I've built this battery plate, which just about perfectly, of course demo syndrome, just about perfectly slides on and off. So I'll show it from this angle here. Right? You actually have this slot here, which interacts with the locking tabs, and it clicks right on. It doesn't come off. And the beauty of it is it's got press-fit captive 1/4-inch bolts, so you can mount it to pretty much anything you want. Now, the first version of this, I made this top plate thin, so I actually have these socket head cap screws sticking up above. The next version will likely have these recessed. And the files for this are available on Thingiverse. I'll put a link in the description box below. But regardless, it goes together pretty straightforward. I actually printed out a bin of parts earlier, so it's actually a bunch of pre-printed components, just like a cooking show. Here's one I prepared earlier. So effectively what's going on here is this part that we're seating fits in between these two plates. Right, once it's held in position, right, this assembly here has socket head cap screws inserted through these side holes, and the entire assembly bolts onto here. Those socket head cap screws interact with the battery. You can see these screws here and here, and they actually slide into this rail right here. So unlike other hacks where I've seen where people will just jam connectors into here and not mechanically latch with the battery, this actually gives you a secure mount to the battery. Even though I don't have video of this, I actually took this assembly with a 2 amp hour battery, put it on the end of a long piece of slotted steel with 1/4-inch bolts, and then just started waving this thing around like an absolute madman, expecting it to fail, but it didn't. So I'm incredibly impressed with this. So I've already built 2 of these. I'm probably going to build a couple more and buy more of these batteries now, because the possibilities really are limitless now. The beauty of this is that these batteries, they have an electronic fuel gauge with a button to actually tell you roughly how much its state of charge is. It's got internal battery management circuitry to prevent over discharge, the cells from going into an unbalanced state, to prevent short circuits, to solve a whole bunch of problems, right? These are features that you can't get with naked, or at least electrically naked, lithium polymer batteries. So the beauty of this is, at least with Anderson power poles, I can interface this with anything else I have. I think I have my DC voltmeter here, so if I just go ahead and plug this into here, my good old trusty Hobby King power meter, I'll set that at an angle where the LCD is visible, and put it to watt mode. You can see it's got 20.64 volts, or is it 8.4? 6.4 volts, right? And I actually did a couple tests which may or may not make it into this video, but effectively these batteries do deliver, you know, the 2 amp hours. They aren't underrated. At the maximum discharge capacity of my equipment, I was able to draw about 2 amp hours out of these batteries. So, you know, they do what they say they do on the label. They're rigid, you know, ironically enough, they're rigid. They've got a strong shock-resistant case. You can't crush them. They're metal can cells inside. I don't want to disassemble these because they are rock solid. I even dropped one of these into water and it didn't die. So, as far as I'm convinced, these are my new battery of choice for portable projects where weight is not the primary concern. If I can afford what amounts to about 1 pound of battery for about 35 watt hours of electrical power, yeah, by all means I'm going to use these, because the charger provided by Ridgid charges these within half an hour. So as long as you're not discharging these faster than you're charging them, you pretty much have limitless portable power for anything around the shop, anything where you have AC power nearby, but you don't want to be tethered. You can just swap out the batteries real quickly. You know, one example would be, if I can find it here. One example that I'm considering is for my portable HDMI field monitor, right? One of these guys that takes 12 volt DC in, right? It has an adapter plate for the standard old-fashioned Sony NPF style battery, but it also can take 12 volt DC in through a bullet plug. So what I'm planning on doing is making a VESA mount adapter and finding a way to effectively bolt this onto the back of here, right? In whatever form factor makes the most sense, probably like this. But by doing that, I can power this monitor, which draws about 10 watt hours off of this 35 watt hour battery. I can drive this monitor for 3 hours, and this charges in 30 minutes. So I'm no longer going to run into issues where I'm using the same battery as my camera and having to quickly juggle these on and off the charger to keep filming in the shop. Because with this and a DC to DC converter down to 12 volts regulated, I can run a portable device like this for ages without having to remain tethered. So that's one of many options, but yeah, pretty much this is this little mini project in a nutshell. Ridgid battery plate. I'll put the link in the description for the actual STL files to be 3D printed. And yeah, it's pretty simple to assemble. You just press fit it all together. There's only really one way to assemble it, so have at it. Until then, until the next video, stick around, see you later. If you like the video, please like, subscribe, and comment.